Welcome back. This will be the final installment on the topic of excluding variables, right? So let's get to the first problem. A school's tornado shelter has enough food to last 20 children for 6 days. If 24 children were to end up taking shelter, how many fewer days would the food last? Now, this excluded variable problem is part of the inverse function uh, area. So you would obviously think if 20 children were to eat whatever food was there for 6 days, if you had 4 more children to the group, that means you now have a grand total of 24 children. Obviously, the food is not going to last for 6 days. It's going to last less. So as the number of children goes up, the number of days goes down. So it's an inverse problem, right? So if you assume days equal some arbitrary value n over the number of children. Okay, this is the expression I'm setting up so that I can use this expression to actually work the entire problem. So initially we have 6 days worth of food. We don't know the value of n. N is a constant, okay? Because these two are inversely related, n is a proportional constant or inverse proportional constant, right? So number of children is 20, right? So 20 children. For convenience, we can disregard the days and children, so n will be 120, right? Now we know the proportional constant. We know the number of newly added count of children. We can then determine how long the food would last. So that means let's substitute for days as x. We know n is 120 and the number of children is 24, so it'll be 5. So x equals 5 days. That means the food, whatever food that is supplied to the shelter, if the children count has gone from 20 to 24, the food would only last 5 days. Is that clear? All right, let's continue. Again, this is another one of those inverse problems. So if x equals 2, y equals 18. If x equals 9, y equals 4. If x varies inversely with y, what's the value of y when x equals 2? Just like we did earlier, we can say y equals n over x. You can pick either this or this, it doesn't matter. So if y equals 18 and x equals 2, n equals 36, right? Now we know n equals 36. Let's go to the section that's asking you to actually solve the problem. So if x were to be 12, what's the value of y given n equals 36? So y equals 12 over x is, n is 36, x is 12, so y equals 3. Isn't that easy? Well, this problem precisely states it's an inversely excluded function, whereas in the previous problem, it didn't state. You have to infer from the problem, right? If x over 3 equals 50, then what is x over 10 equals? Well, x over 3 equals 50. If you multiply both sides by 3, then we get x equals 150. So x over 10 would be 150 over 10 equals 50. It's a very simple problem, but nevertheless, not all problems on a SAT exam or 10 out of 10 difficulties. You also need to know how to solve some of the easier ones. So this was one of the problems on the excluded variable that I thought was very easy, so I figured out threw that in as well. All right. We've solved some expressions. So let's go ahead and solve this problem. As I always said, when you have negative exponents, convert them into positive, which aids in solving the problem in a more easier fashion. So we have a squared over b cubed multiplied by a raised to the power -2 divided by b raised to the power -3. We do not even have to disturb this. Let's keep it as it is, okay? So that means, or you can do one thing, you can do one or two things. You can solve the problem in more than one way, okay? Now that I think about it, I find this way easier. So inside the first bracket, retain the numerator as it is and bring the denominator to the numerator. That means it'll be b to the -3, right? Let's leave that as it is. Now let's go to the second one. we have, again, leave the numerator as it is and bring the denominator to the numerator, which will make b to the -3 as b to the third. Now we can combine like terms, a to the 2 times a to the -2 times b to the -3 times b to the 3. Since bases are the same, we can add the numerator. So it's 2 minus 2 times b, 3 minus 3. This is 0 times 0 equals 0. So the answer is C. Okay. Change to a mixed number, 34 over 5. Okay, so how do we do it? Well, the easiest way to solve this sort of problem is to actually use the answer choice themselves. So if you take choice A, it's 6 4/5, right? So if you multiply 6 times 5 times 4 is essentially 6 times 5 plus 4 over 5. That's 34 over 5. Well, I was experimenting and the first choice happened to be the correct answer, so that's done. What's the average of 2 over 3 and 5 over 6? So essentially the problem is asking you to do this, right? As I always said, take one step at a time. Since the denominator is rather a simple value of 2, if you could just solve the numerator separately and then plug it back in, you can get the final answer, right? So it's 2 over 3 plus 5 over 6. The common factor is 6. So it's 3 times 2 is 6. So 2 times 2 is 4. 6 times 1 is 6. So 1 times 5 is 5. So it's 9 over 6. We can reduce this even further. It's 3 times 3. This is 3 times 2, right? So it's 3 over 2 divided by 2. Now, because we don't have a value below the 2, we can just arbitrarily assign value of 1. Now this gets into an expression that you're all familiar with. So retain the numerator as it is and flip the terms of the denominator. So it'll be 1 over 2. So it'll be 3 over 4. And the answer is C. All right, well, that concludes our session on excluded variables. I'll see you with another topic. If you've learned something, subscribe to my channel and please share the video with your family and friends. And thank you for watching. I'll see you with another topic. All right, so stay tuned.